Hi and welcome to today's video. We are still looking at vector component method of vector addition. Today's problem reads, a displacement d of 135 meters at 25 degrees south of east is as a result of 4 successive displacement. The first is d1 of 75 meters at 25 degrees north of east, d2 of 90 meters south, d3 50 meters at 30 degrees north of west, and the displacement d4. Find d4. The steps that we're going to follow are outlined here. The first step is to draw the vectors on an xy plane. The second step is to draw the vector component table. The next step will be to calculate the resultant in x. Now here is where things shift. We've already been given the resultant, which is the displacement d. So picture it like this. When we draw our vector component table, once we have all the vectors, d1 will be here, d2 will be here, d3 and d4. We have d, which is the resultant. The one we're looking for in this case is d4. We've been told to find d4. We already have the resultant. We'll follow the same procedure, but in this case we'll find the resultant for d4 and the resultant for d4 in x, which is going to be here, resultant for d4 in y, which is going to be here. We'll use the same formula here, except it will be d4 is equal to the square root of d4 in x squared plus d4 in y squared. That's how we'll get the value of d4. Finally, we also get the direction in which d4 is, so that we can put the degrees. So if it will be 30 degrees or whatever angle that will be, we have to put it there as well. With that in mind, let's get into it. The first step, draw the vectors on an xy plane. We have our xy plane there. The first vector, let's begin by drawing d, which is the resultant. 135 at 25 degrees south of east. So we can also include our compass, north, east, south, west. So south of east, we have to go to the east line, which is also the positive x-axis, then 25 degrees south of east. So 25 degrees going towards the south of east. So this is our vector d. This is 25 degrees. The next one is d1, which is 25 degrees north of east. So we go back to the east line, but this time around we go 25 degrees to the north of east. So this is also 25 degrees, and this is d1. The other one is d2, which is 90 meters south. So 90 meters south is the south line. So 90 meters south. Then d3 is 50 meters at, and this is d2. 30 degrees north of west. So we go to the west line, then 30 degrees north of west. So towards the north of the west. So this is 30 degrees, and this is d3. Now we want a vector d4. So we don't know where d4 is. So let's just say it's somewhere here. We want to calculate d4, but we don't know what d4 is, and that's the one we're looking for. I'm not sure if it will be here, but just to show you that this is what we're looking for. So we've completed the first step, draw the vectors on an xy plane. Next, draw the vector component table. vector component table. The first column has vector, the second one has x component, the third one y component. Then the first row has the vector d1, the second d2, the third d3, the fourth d4, which we're looking for, and finally d, the resultant. Now let's get all the angles and the components. So the x component of d1, what's the angle? Remember, the angle is measured from the positive x axis. What was the magnitude of d1? d1 was 75 meters, so that's 75 cos, and the angle is 25, making our y component 75 sine 25. Next we go to d2. d2 is south, so this is the same as 270 degrees. So from the positive x-axis, it starts from here, goes all the way up to there. That's 270 degrees. So this becomes, and the magnitude of d2 was 90. So that's 90 cos 270. Y component is 90 sine 270. d3, from the positive x-axis, if we measure from here all the way up to here, that's 180 minus 30, which is 150. So this becomes d3's magnitude is 50 meters. So the x component is 50 cos 150. Y component 50 sine 150. d4, we do not know. D itself is 135. 135. The x component will be cos. Now what's the angle? This is 25 degrees here, but from the positive x-axis, if we go like this, we'll have to subtract 360 minus 25. This gives us 335. So this is 335. And this is 135 sine 335. Next, the resultant. Now the resultant is gotten by d is equal to d1 plus d2 plus d3 plus d4. Now remember, we have to get the resultant in x first, then the resultant in y. So this will be d1 in x, d2x, d3x, and d4x. So what's dx? This is 135 cos 335 is equal to d1x is 75 cos 25, d2x is 90 cos 270, d3 you can use your calculator. So let's put d4x here. d4x is 98.6. Next, we need to find d4y. By the same process, d in y is going to be equal to d1y plus d2y plus d3y plus d4y. dy is 135 sine 335. d1 y is 75 sine 25. Okay, now that we have d4x and d4y, we can find d4 itself, which is equal to the square root d4 in x squared plus d4 in y squared. This is equal to, and that's the value of d4. However, we still have to find the direction. So tan theta is equal to ry over rx. Ry is negative 23.8. However, we'll ignore the negative in this case, and you'll see why in just a minute. So this will be 23.8 over 98.6. To get the final direction of d4, we have to look at the values of d4x and d4y. d4x was 98.6, d4y was negative 23.8. Draw ourselves an axis, then we check. d4x is 98.6, which is positive, so it has to go in this direction. d4y is negative, meaning it goes down the y-axis. That makes d4 itself has to lie in this quadrant. But remember that this angle theta always relates to the x-axis, so it is here. So if you want to report this angle with relation to the positive x-axis, we have to say from the positive x-axis going all the way up to there, that's 360 minus 13.57 degrees, which gives us 346.43 degrees. The final statement has to be d4 is, the magnitude of d4 was 101.4. So that is d4 is 101.4 meters at 346.43 degrees from the positive x-axis. Or you can also say d4 is 101.4 meters at 13.57 degrees south of east, because it comes 13 degrees towards the south from the east.